So, good afternoon. Good afternoon to everyone. So, today we are entering into a very important session, very good session. So, however, this session is very important. You people, please pay attention towards this particular session because we may take some mathematics which is related to cryptography. Okay, however, before going to that, security services and mechanisms. So far, we have studied something about how the attacks will be and what is the premises of cryptography and everything has studied. Now, today, what are the security services and mechanisms which are available with cryptography and network security? Actually, the security services and mechanisms were proposed by one company. That company is the International Telecommunication Union, ITU. ITU, telecommunications standard sector. This is the specific company which was given or describe some kind of security mechanisms information. Based on that, the cryptography has taken and have produced some kind of security services and mechanisms. And the security services will be ITU X800. So this is the actual document where exactly you could find the security services. These services will be data confidentiality, data integrity, authentication. Already we have seen non-repudiation and access control. So how these services will be enforced, the security will be studied today. So previously data confidentiality will be taken, some kind of attack will be there on data confidentiality, integrity also, and many other things also be there here. Let us today study something about security services and mechanisms. So look at this. So data confidentiality in the sense, the production from data from unauthorized disclosure. Unauthorized in the sense the person who is not authorized to access such kind of data. So we are trying to avoid such kind of people from the accessing. So how this could be done? Today we are looking forward for many security issues here. So if you do know so-called password of one particular person, immediately people will, the concerned people will send one OTP. OTP could not be accessed by you. So that OTP will be there with the person who has that SIM card, something like that. So that is called as a confidentiality. How it could be maintained. So unauthorized disclosure of that particular data. So it has been done by many ways. So we will see in future, we will see how this could be avoided. We will see. And then connection confidentiality. So first data confidentiality will be connection confidentiality. So here connection in the sense of two different types of connections are available here for us. That is one is a TCP connection and second one is UDP. Already we know TCP is a very secured connection where the client and server will be continuously communicate with each other without interfering any other people. So it is obviously secure. But in UDP, so it could not be identified. Sometimes how you could justify this not secured in the sense all mobile ad hoc networks are UDP networks. Mobile ad hoc networks in the sense landline networks are TCP networks and mobile networks are so UDP networks. As and when you are trying to talk with anybody, sometimes people will be, some other calls will be overlapped to our area, so that we will listen some other people voice out there. So such kind of things are available. So there are many researches which are being going on for this UDP to make security services and mechanisms on UDP also. So right now, still some more security data disclosure will be there in UDP. Then followed by connectionless service, of course, just I have given, that is UDP. And selective field confidentiality. Selective field in the sense, if data is being processed the data must be divided into several number of blocks, several number of small pieces, because sender's block size and receiver's block size may not be same. So that the sender's block size or receiver's block size will be a difference in the sense based on the smallest block size from each side, the data will be make into slices, and each slice will be sent to either sender or receiver, something like that. And after receiving everything, then it might be so combined back and sent to the user for his own purpose. During that transmission, so how the data is being secured, so that could be also taken care while we are talking about this particular data confidentiality here. Then traffic flow. Traffic flow, already we have seen traffic flow in the sense, in traffic flow, generally the hacker is trying to, observe where the data has been transmitted, from where to where the data has been transmitted. Continuously, he's sensing the network to identify the base station. So if once the base station will be gets identified, obviously so-called hacker will be send huge number of requisitions to the base station, so that network will be gets slow, and obviously remaining all people who are working with that particular base station will be gets struck while working with that particular base station. So such kind of confidentiality also be maintained, so while doing some kind of work with traffic flow. And data integrity, in the sense unauthorized activity could not be done in terms of modification, in terms of insertion new data into the block, or deletion some data from the block, or any replay, same kind of data will be stored, and again and again replaying could be happen, something like that will be gets avoided. Everything is here, services, in the sense these are the services you have to follow while you have to construct any cryptographic system. That is what the point is here. Okay, and how you have to provide all this, we will see next unit of course. Okay. So connection integrity and with recovery. So connection integrity, in the sense as and when secure connection between one user to another user, if there is any possibility to have leaking, so that leaking should be always take care by the connection itself. And non-repudiation, both parties must be agree to communicate. So that is what the non-repudiation. And however, so many other services also be there. We have already seen some attacks and services already seen in the previous sessions. Okay, however, we will see each and everything forthcoming units onwards. So this is what about introductory part only. Now we'll enter to this one. This is very important for you. You please pay attention towards this. Of course, you know many issues, but you are expected to pay some attention while I am discussing. So cryptography, in the sense, it is completely based on mathematics. It is completely 100% based on mathematics. So while I'm discussing something, don't feel bored, because very fundamental mathematics too. So highest level mathematics are going to be discussed with you, so that don't feel any bored. So first and foremost is integer arithmetic. How integer arithmetic could be done, and what are the different kinds of operations which are being done with integer arithmetic. Normally, integer arithmetic can be involves only 3 operations. However, before going to that, so set of integers are denoted by z. Set of integers are denoted by the z, and this z will be all integers from negative infinity to positive infinity. Something seems like this. Okay, something seems like this is the set of all integers, which could include negative numbers, 0, and positive numbers. Panduranga Gaud, he's trying to, okay. So here, what actually binary operations here, only 3 binary operations could be done here. Basic or fundamental binary operations are addition, that is add, subtraction, minus, multiplication. So if you perform these 3 on integers, you could get integer as output. Remaining, division. So probably that they should not have any possibility to get integer as output, but here it could be in addition, subtraction, or multiplication, you could get integer as output. For example, you could consider something here. So the Z will be the set, and you maybe gets operate two operands. Into the aduga please ante ento idi agu adugu please what does it means? Which sound is coming? Probably I may not from my side. What kind of sound you are listening? Huh? What kind of sound you are listening? A machine sound. Yes, it is there. It is there. Yes. Oh, however, binary operation in the sense, this binary operation would always take two inputs and creates only one output. So two inputs must be taken, or two parameters must be taken by the binary, and one output must be produced as far as decimal is supposed to be considered. Whereas if you go ahead with actual binary operation, I mean zeros and ones, two inputs will be taken and two outputs will be produced by the binary. But here only two inputs and one output. So however, these operations are supposed to be comes under integer arithmetic, and these operations will be produced only one output, and this output also be followed on with so-called the integers. Okay, either it is positive or negative, it could be followed on with this particular integer. So this is the point you need to identify. So integers will always so negative infinity to positive infinity in addition to 0. So operations of integer will be these three only. And if you are supposed to consider, regarding to division, this division could be always taken into consideration something like this. So A will be divided by n. If A will be divided by n, so we could have a quotient Q and remainder R. So as far as integer is supposed to be considered, let us consider, so 5 will be divided by 2, something like this. So normally, if you are supposed to speak something pure mathematics, so 2.5, so here it is 5, and obviously it could be 0. So this is the answer where exactly you have to consider. But here, you are not supposed to take into consideration this 0.5, because integers does not have any rational numbers. I mean P by Q format numbers. So that is why here it could be always specifies something like this. So look at this. So 2 2s are 4 and 4. So here it is, remainder is 1 and the quotient is this one. So as far as the division is concerned in terms of what do you call integers, so there is no decimal place, so that we would like to take this particular kind of operation here, and the relation will be seems like this. A will be equal to Q into N plus R. Q into N plus R. Okay. So why we have taken something like this in the sense, where this integer division could be taken into consideration here in the sense, normally, so any division operation, DIV followed by 5 comma 2 will get operated by assembly level programming language. So actual quotient will be stored at AX. So AX will be having quotient, and BX will be having what is that? The divisor. Divisor is actually it is 2. So the divisor, sorry, this is the divisor, and followed by CX is having so the dividend in the sense A. So dividend, and DX is having so the remainder. Remainder R. So actually, as far as the original division operation which is being done by integers in assembly level programming languages, it could be seems like this. I'll show you. I don't know whether debug is working with me. No, debug is not working with me. So if debug is working, wait for a while. No. Okay, debug is not there. Tomorrow I shall upload. I shall install debug for you and I'll show you. Okay, just wait for a while. I'll look for one more kind of thing. So here debug will be available. Debug. No, okay, debug is not available with me. So I will load debug for you. Then you will see how the integer division could be gets happen in terms of specific integers in any language. So normally accumulator could be stored. So the coefficient base register could be stored. The division cx will be stored. The dividend and dx will be stored. The remainder. Okay, everything will be separate values. There is no decimal value in terms of integers. So that is why this equation has been drawn. Okay, that is the way. So this equation has been taken into consideration. Now, as and when in cryptography, if you perform the same kind of operation, so there are some restrictions. So those restrictions are so so if you require the divisor, it must be positive integer. That is the first point we need to consider. So, and if any remainder will be there, it must be always non-negative integer, either 0 or more than 0. Okay, it must be 0 or more than 0. So these 2 points must be there while we have to apply the same integer division in terms of cryptography. Okay, where it could be utilized for you in the sense you can see this one in third chapter or third unit, and then when RSA, SHA, and MD5 will be come across with us, then we will see how these could be utilized. And then followed by divisibility. Divisibility is different from integer division. Divisibility in the sense, so if a is non-zero, then remainder r will be equal to 0. Remainder r will be equal to 0 in the sense, so if a will be divided by n, then remainder r will be equal to 0 in the sense, so n is completely divides this particular a. That is the meaning. That is the actual meaning here. So r will be equal to 0 in the sense, that is the meaning. So therefore, a will be equal to q into coefficient value into n, whatever the divisor you have considered. So that is going to be taken into consideration. Now, then a can be divides a, n can be divides a, then this can be written as like this: a pipe symbol followed by n. In terms of mathematics, it could be a divides by n. So that is the meaning here. Sorry, n divides by a. So this is the meaning. So within this particular point, there are certain properties. Property number 1, if a divides 1 divides a, then a will be equal to plus or minus 1. So 1 divides a properly. So minus 1 divides so 1 in the sense. So 1 1 the 1. So minus 1 the 1 minus 1. So remainder will be equal to 0. This divisibility will be always aiming for r equal to 0. R must be equal to 0. Otherwise, these properties could not be worked out. Okay, that is what you need to remember. Then followed by if b divides a and a divides b, then a will be equal to plus or minus b. So b divides a completely and a divides b completely. Obviously, we could consider a will be equal to plus or minus b. Both will be same. That is the meaning here. Two different types of integers you have to consider. A will be equal to 5 in the sense, b also be equal to either minus 5 or positive 5. That is the meaning here. Then a divides b, this is a transitivity. A divides b and b divides c, then obviously so c divides a. So let me give you one small example, then you may be understand. So a will be equal to some 15, So b will be equal to some 5, sorry, some 6. No, it could not be worked out. I think it could not be worked out. Okay, wait for a while. A will be equal to some 20, and b will be equal to some 10, and c will be equal to some 5. In this regard, so b divides a successfully. That is 20 by 10 is equal to 0 successfully. At this, in this context, c divides b, so it could be successfully, because 10 by 5 will also remainder also equal to 0. It is also successfully. By taking these two equations, you could conclude that so c divides a fully, I mean completely. That is 20 divided by 5 equal to also 0. So this is called as transitivity. First two conditions will be get satisfied in the sense transitively. So third condition could also be get satisfied. That is the meaning here. So transitivity could also be worked out provided this condition will be true. This condition is always getting true. Then only we would like to consider all these properties. And final property will be if B divides A and C divides A, then so M into B plus N into C, this whole expression will be divides A completely, where M and N are some arbitrary elements. Okay, so this is what you have to consider. These are the four properties in terms of divisibility. These are the four properties in terms of divisibility, and we would like to use this divisibility and this divisibility in RSA algorithm. In RSA algorithm, these two divisibility properties are supposed to be used by us. Okay. Then GCD, very important in cryptography. Main role is this GCD only. GCD, and one more very important point is congruences. Congruences will be discussed to you by tomorrow. So congruences, I mean modular division is also called as congruences. Congruences and GCD are very important for us, because you have two questions in our final examination also. Explain Euler's rule, explain Chinese remainder problem. So these two problems are there with you in our final examinations also. Pay attention. So GCD, in the sense everybody has no a GCD of two positive integers. It could be gets operated on only positive integers. So the largest integer which could be divide both integers will be, I mean, so consider divisors of one particular number. A and B are two different types of numbers. A is one number, B is another number. So these are positive integers. So consider all divisors of this one and consider all divisors of this one. Some divisors will be gets equal. So in equality, which divisor is very biggest one, which is being divisible by these two, then that is called as GCD. Okay, and identifying this particular GCD will be a very important point here. So by taking all divisors which are useful for this one, by taking all divisors which are useful for this one, I mean divisible for this one, collecting all those things and segregate what kind of divisors are gets equal, and identify what is the maximum value, something like this. For very biggest numbers, it is somewhat tedious. I'll give you one example, then I'll move forward. Okay, so let us consider, if you take into consideration some A will be equal to some 10, B will be equal to some 20. So divisors of this one is 1 is divisible, 2 is divisible, so 5 is divisible, and followed by 10 is divisible. Then here in converse, this one 1 is divisible, 2 is divisible, so 4 is divisible, so 5 is divisible, and then 10 is divisible, and then finally 20 is divisible. So these are all divisors of so A, I mean 10. These are all divisors of so the 20. Common values within this one is common values will be 2, 5, and 10 are common values. Sorry, 1 also be there with us. 1, 2, 5, 10 are common values. Out of these common values, again, we need to identify what is the maximum value. So maximum value is again 10. So we need to perform approximately 3 different types of operations here. First operation is identify. This is the first operation. Identify all digits of both numbers. And the second operation is what are the common values, common divisors for these numbers, we need to identify them. And third operation is which is the maximum element which is being available in a common. So it is also B. So 3 operations. So to avoid this kind of confusion, actually this is the operation for identifying the greatest common divisor before inventing this Euclidean algorithm. So to do this particular tedious process, Euclidean is he is the person. He is the Euclidean in 345 BC. So he was identified this particular algorithm. So that algorithm is finding of a GCD of 2 positive integers by taking by listing all divisors is practically somewhat so not impossible. It could be possible, but it will take huge amount of time. So to reduce that particular time, he was introduced to an algorithm. That algorithm is so Euclidean algorithm. So this one. What is the fact here in the sense? Fact 1 equal to, so 2 parameters will be taken for GCD, A and 0. If A and 0 will be there, A will be the GCD of those 2 numbers. Otherwise, GCD of A comma B will be taken. Then you have to identify B and remainder, where remainder is after B is dividing A, we maybe get some kind of remainder. So you need to set that particular value something like this. Then obviously this remainder will be, sorry, this B will be so your answer when this remainder will becomes to 0. Let me explain this one by taking one example. Then you could understand very easily. Okay, let me explain this one. So how this could be gets operated. So let me take into consideration here. What exactly we are supposed to get operate here. So basically, you may be taken 2 values into consideration as like as just before what we have taken here. 10 and so 20 has taken. 10 and 20 has taken here. While writing, so my mouse is not supporting me properly. 20 has taken here. So biggest value is 20 and 10 will be divisible by 20 properly. So therefore, so it could be adjusted to 20 and 10. So always B parameter will be so smallest one and A parameter will be always biggest one. You need to adjust something like this and you could get remainder or something like this. R will be some 10 here. Remainder R will be 10 here. So now what exactly we're trying to do in second call, what exactly we're trying to do, this parameter will be passed in terms of so 20 and this remainder will be passed in terms of this one here. Obviously 10 will be taken here and again 10 will be taken here. So the remainder will be 0. Okay. Then obviously what exactly we're trying to perform here, this parameter will be passed here, B will be passed as A and this remainder will be passed here. Obviously we could consider so 10 comma so 0. Already when R will be becomes 0, then this value will be so the output. So that is the greatest common divisor. So by intuition, so how it could be specified, how this could be specified here in the sense, this is the way. So some R1 will be equal to first value, that is A. R2 will be equal to second value, that is B. And by taking GCD of R1 comma R2 instead of A and B, R1 comma R2, you may be get R as parameter. R as remainder. Then in next step, this is the initial step. Then in next step, what you are supposed to do, this value can be submitted as R1 and this remainder will be submitted in terms of R2 here. So R1 will be taken B, R2 will be R here. Okay. After doing some kind of operation here, again you will get R, and after doing some number of recursive calls, something like this, obviously this value could be get here. The value R2 will be get here, and so whatever they are, R will be get here. So you maybe get some kind of output. That output will be 0. This is R1. Sorry, this is R1. So this is R1 and this is R2. This is R2. This will be. And final step will be R2 will be set to R1 and this 0 will be gets followed this one. One condition will be if R2 will be equal to 0, R1 is the answer. So you just remember or you just recall yourself regarding to what is that? Uh, uh, Recursive algorithm. Recursive algorithm. So recursive algorithm can be seen in such a fashion. This is the fashion. Finally, answer will be this one. Whatever the value which could be there with so R1, that could be the answer. So in this way, Euclidean algorithm can be gets worked out here. So Euclidean algorithm can be used everywhere else in what is that? Cryptography and network security. It must be there. It must be there. Okay. So here, one example is given here actually. I do not remember this one. Okay, you can see GCD of 36, comma 10. It has been taken. So these two will be gets applied. Then we got 6 as a reminder. 36 divided by 10. So 3 times of 36 will be the remainder. So this will be forwarded in terms of in place of 36, and this will be forwarded in place of 10 here. So now A will be 10. I mean R1 will be 10, and R2 will be 6. Okay. Now 6 ones are 6, and remainder is 4. At this place, 4 will be the remainder. And now you can forward this particular value here, that is 6, and you can forward this value here, that is 4. Okay. Now 4 ones are 4, remainder is 2, so 2 will be the remainder. So this value can be forwarded here, that is 4, and remainder R will be forwarded as remainder 2, that is 2. 2 2s are 4, remainder will be 0. 2 will be forwarded here, so that is 2 here. So this is 2, and 0 will be forwarded here, that is 0. Yes, second parameter will be becomes 0. So first parameter will be the answer. So greatest common divisor for this particular problem is 2. In this way, actually this is a recursion. So we are not supposed to call this as recursion, because recursion is not supposed to be taken into consideration by cryptography and network security algorithms. Everywhere you can say recursion, but cryptography could not be mentioned that. It has been applied recursion implicitly, but explicitly you are not supposed to mention that particular point in terms of evaluating something in cryptography. So this is what the specification. Tomorrow, modular division could be done, and congruencies also be done. After the completion of modular division and congruency, then we will look at this. We will complete this mathematics of cryptography. It has been completed. Unit 1 is very simple. Previously, Unit 1 is very big one. Right now, it is very simple. Very simple one. So we'll complete by tomorrow itself. After completion of this whole thing, I'll give you the notes also. Notes will be forwarded to you by Google Classroom. Okay. Notes must be forwarded to